Alright, in today's lesson we're introducing the law of exponents. We'll be doing radicals in our next lesson, and then we'll go on to logarithms. And so this leads into all of that. First of all, on our law of exponents, we have 6 laws we go by. When we are multiplying bases with exponents, you add the exponents. So for example, if I'm going to use an example here. If I have 3 squared times 3 cubed, then my answer will be 3 to the 2 plus 3, or 3 to the 5th. And you can see, I'm going to go down here, I'm going to erase it eventually just because it'll make all the notes too crowded. But if I have 3 squared, that's 3 times 3, that's your 3 squared. 3 cubed is 3 times 3 times 3. And you can see that altogether that's 3 to the 5th. So what you look for in this is bases that you're multiplying by each other. You add your exponents. These two you tend to get confused, the law 1 and law 2. An example of law 2 is if you have parentheses, and I'm going to use, because this is the two numbers that really get confused a lot. If I have 3 squared raised to the 3rd power, that's not 3 to the 5th, that's a to the m times n, or 3 times 2, which is 3 to the 6th. Now let me just write that out so you see why that is. It's 3 squared cubed, so 3 squared is 3 times 3, and I multiply that by itself 3 times because it's cubed, so 3 times 3, this is 3 squared, okay, times 3 squared again, which is another 3 times 3, times another 3 squared again, which is another 3 times 3. And you can see that now I have 6 3's. And so that's a shortcut, that you don't have to expand all this out to get the right answer. You multiply your exponents here. So remember, when you have a parentheses, see there's no parentheses in law 1. If you have a parentheses raised to a power, then you multiply. So if you have parentheses, okay, you're going to multiply. Let me just look at that. See if I can. You multiply, okay? If you don't have parentheses, then you're going to add. No parentheses, you're going to add, okay? So hopefully, I don't know if that's going to help you remember, but look for your parentheses, and that's when you're going to multiply. Now, a times b to the m power, let's go on to law 3. That just means everything in the parentheses is raised to the m power. So if I have 3x squared to the 4th power, then I have 3 to the 4th power, which is 81, and x to the 2 times 4, because that's a parentheses, raised to a power, so I multiply x to the 8th then. Let me take this little stray mark off so it's not confusing. Okay, x to the 8th. And then I have to expand that 3 to the 4th because I'm not going to leave it like that. That's 81x to the 8th. Okay, so that's what we have when we have our laws of exponents. Now, I think I need to change that background because that purple really does hide my writing. I mean, that black really does hide my writing. So I'm going to change the background to purple so you can see when I write on it. Looking at law 4, we're going to skip law 4 and go to law 5 for right now. Law 5 when you have a division problem, it's a to the m minus n. So, for example, if I have... Alright, when we have quotients, again, we're going to subtract. So, for example, if you have a to the 5th over a to the 3rd, you have the answer is a to the 5 minus 3, or a squared. You can also think of it that you're going to subtract the two exponents and put the answer on the side with the biggest exponent. So if these were reversed and you had, I'm going to move over here into the purple area, if you had a to the 3rd over a to the 5th, your answer would be a to the 3 minus 5, or a to the negative 2. Okay? But also, if you think about that, and this is going to help us for tomorrow when we're talking about negative exponents, that's 1 over a squared, because you subtract the two exponents and you put your answer on the side with the largest exponent, which would be the 5. So a to the negative 2 is equal to 1 over a squared. And we'll get into more of that tomorrow. Now let's go back to Law 4. Law 4 is anything to the 0 power is equal to 1. And the reasoning behind that is, suppose you have a to the 6th over a to the 6th. That's a to the 6 minus 6, or a to the 0 power. Now, when you have any value over itself, you know that they cancel out and they're equal to 1. So that's why anything to the 0 power is 1. It could be 468 million x to the 736. It really doesn't matter. Whatever's in parentheses or whatever's raised to the 0 power is 1. Now, Law 6 is much like Law 3, only it has to do with a division problem. A divided by b to the m power means you can rewrite that as a to the m over b to the m. So if I have, and I'll go down here for an example, if I have 3x over y squared, and all raised to the 4th power. Well, we know 3 to the 4th is 81, so we've done that already. But I'll write it out. That's 3 to the 4th, x to the 4th, because this is x to the 1st here. If there's nothing written there, it's a 1. Over y to the 2 times 4, or y to the 8th. Now, I can't do anything with the x and y. If there were a y on top or an x on the bottom, I'd need to simplify and basically reduce the fraction. But I need to expand the 3 to the 4th, actually get a number. So that's 81 x to the 4th over y to the 8th. Okay, so that's some examples. Let's work through some problems. We want to simplify the following. Now, when you have negatives, many times it's easier to think of it as negative 1 times 4, because sometimes negatives can throw you when you're working these problems. So I'm going to think of that as negative 1 times 4. And this one is negative 1 cubed times 4 cubed. That's going to take care of those cubed features. Now, negative 1 cubed is negative 1. Negative 1 times negative 1 is positive 1. So that's going to be 1. Now let's look at our 4s. 4 cubed is alright, so when we simplify this, we have 1 times, and then that's going to be 4 to the 4th power, because that's to the 1st if there's nothing there. And so 1 times 4 to the 4th is going to be 256. Okay. Now, Here we have negative 3 squared. Well, negative 1 squared is 1, so negative 3 squared is going to be 9. So that's going to be 9 cubed, or negative 3 to the 6th power, which then it will become positive. And so 9 cubed, or negative 3 to the 6th, is 729. Now you can enter this in your calculator. If you enter a large exponent like this, be sure you put your negative in parentheses, and then use the little hat key that you see, put your exponent in, and then you'll hit the enter key. Okay? So that's how you would enter exponents into your calculator other than squared, because you have a key for squared. Alright, looking at number 3, we have 3 squared, and then everything x squared y, and everything inside parentheses is squared. So you have 3 squared. Squared is going to be 3 to the 4th. X to the 2 times 2 is x to the 4th. And y to the 1st squared. Remember, parentheses to a power, you multiply these exponents, so that's going to be y squared. Now we're not going to leave it like that. We're going to go on and we're going to make our 3 to the 4th the number that it is, because we can evaluate that. That's 81. And then we'll have x to the 4th y squared. Okay? Now looking at our last problem here on the page, and it's actually the first problem on the next page too. I just kind of doubled up for us. When you multiply fractions, you multiply across numerator and denominator. So this is going to end up being m to the 7th times 1, or m to the 7th, over 1 times m to the 4th, or m to the 4th. Now, remember, when you have a division problem, you subtract your exponents, so that's 7 minus 4, and that's going to end up being then m cubed. Okay. So that's our first worksheet. First part of the notes for 8-1. Now let's go to the second page. You'll notice we've already done 4, so we're not going to do that one again. We're going to start with number 5. Alright. Now, this is a distributive property problem. We have all of this piece here, this x, y squared, and that's got to be multiplied by each of those elements in that binomial. So I'm going to write all that out just to show you how that goes. Let's see if we can get this. So we're going to write it out. And what that's going to look like then is xy squared times the first element of the binomial, which is 3x squared. And then we'll have plus xy squared times the second part of the binomial, which is 2y squared. Now we'll multiply each of those pieces. So when we multiply these two, we have 3. This is multiplying, so we add the 1 and the 2, and it becomes x to the 3rd, and we still have a y squared, plus, now we have 2x y to the 4th. Okay, and then you look to see if you can combine these in any way. Well, remember, you cannot combine unless the terms are exactly the same, and these terms are not identical. This is an x cubed, this is an x squared, y squared, y to the 4th. So we cannot combine, so our answer is this. Okay? And so let's write ourselves a note. We can't combine them. Let's see if I can get it where it's going to write. Can't combine because they're not, like, which means identical. They have to be identical terms. The variable with the exponent has to be exactly the same. Okay. Now let's look at this. We've got everything in here raised to the 0 power. Remember, anything to the 0 power, no matter what's inside those parentheses, is 1. You don't even have to think about it. That's your answer. All right, now we're going to look at something with a variable in the exponent. So this becomes a little challenging. People usually think this is difficult, but it's really not. The bases are the same. You check that the bases match. If you know they're the same, then the rule is when you multiply, you add the exponents. So this is 4 to the y plus 2 plus 6. Okay? Well, take the parentheses away, and that's 4 to the y plus 2 plus 6. All right, we combine these numbers, so my final answer is 4 to the y plus 8. And that's the final answer for that problem. So now let's look at number 8. Number 8, all of this is over 1. So we have to evaluate our parentheses and raise them to the exponents first. So let's do that. Parentheses to a power, you multiply the exponents. So we have a to the 8th over b to the 6th. That's one term. And that's multiplied by a to the 2 times 3. Let me erase those so that we see better those exponents. That's a to the 6th b cubed over 1. Okay. Now I'm going to multiply those together, multiply the numerators together. Now it's not parentheses raised to a power, it's a straight multiplication, so I add the exponents. So that's a to the 14th b cubed over b to the 6th. And then we have b's in the numerator and denominator, so I need to do that division. I need to simplify or reduce the fraction. So I have a to the 14th over, subtract the exponents, and put the answer on the side with the largest exponent. So the largest exponent is our 6 right here. So my answer is going to go in the denominator. Difference between 6 minus 3 is 3, so b cubed will be in the denominator. And that's my answer for that problem. The last one, we're going to use the laws of exponents to solve. Remember, bases are the same. Let's just look at the left side of the equation here. Okay? So when we look at that, the bases are the same. That means that 3 to the x plus 2, that's how we're going to combine those, must equal to 3 to the 8th. Well, now if our bases are the same, okay, if our bases are the same, let me undo that. Okay, let me lighten this up just a little bit, make it lighter. If we have the same bases, okay, that means, and there's an equal sign in between them, then these must be equal to each other. The exponents must be equal to each other. So if the bases match, you can set the exponents, and we have this equal sign in between. So the conclusion we can draw is then that x plus 2 must equal 8, and so subtracting 2 from both sides, x equals 6. Well, plug a 6 in here for x. 3 to the 6 plus 2 equals 3 to the 8th. And so that's a good answer. Okay, that's the end of this lesson 8.1.